For the given question, we are going to find the power factor of the series LCR circuit at resonance. We know the formula for power factor, which is equal to R by Z. Z is nothing but impedance of the circuit. So Z equal to square root of R square plus XC minus XLB whole square. So here XC is nothing but capacitive reactance, which can be written as 1 by omega C. And XL is nothing but inductive reactance, which is nothing but omega L. And we know that the value of omega is 2 pi F. Now the question is, find the power factor of the series LCR circuit at resonance. We know that at resonance XL will be equal to XC. So if we substitute this, we get Z equal to square root of R square plus 0 square. So we have Z equal to only R square, and if we take square root, we get Z equal to R. So from this we can get the power factor. We know the value of Z is R, so we can substitute R by R here. So if we cancel out, we get 1. So the power factor of the series LCR circuit at resonance is equal to 1. So the answer option A is the correct answer.